The possibilities of using AI to solve exciting real-world problems are endless. Imagine solutions that analyze images, comprehend speech, make predictions using data, and imitate other intelligent human behaviors.
Artificial intelligence empowers amazing new solutions and experiences, and Microsoft Azure provides easy-to-use services to help you build solutions that seemed like science fiction a short time ago, enabling incredible advances in healthcare, financial management, environmental protection, and other areas to make a better world for everyone.
The ability of AI and machine learning to discern patterns in complex data sets allows scientists to make better predictions and more informed recommendations.
Using AI and machine learning to improve decision-making helps to ensure the best outcomes possible for some pressing global problems. With the right knowledge and skills, you can be part of the solution.
As organizations and global role players rely more heavily on AI, Microsoft Azure AI professionals will be among the most sought after in the coming years.
Career opportunities in AI cover a broad range of roles, from developers and engineers to data scientists.
To help you master the fundamentals and jumpstart your career, Microsoft and Coursera have partnered to develop this program. It is a beginner-level program that is suitable for candidates with both technical and non-technical backgrounds who want to learn about Microsoft Azure offerings and get hands-on experience with the product.
Microsoft certifications give you a professional advantage by providing globally recognized and industry-endorsed evidence of mastering skills in digital and cloud businesses.
Whether you're just beginning to work with artificial intelligence or you already have AI experience and are new to Microsoft Azure, this program will act as a bedrock of fundamental knowledge to prepare you for the AI 900 exam.
We've assembled a great team of instructors to prepare you for this exam.
Hi, I'm Karen. In Course 1, you'll learn the key AI concepts of machine learning, anomaly detection, computer vision, natural language processing, and conversational AI. You'll see some of the ways that AI can be used and explore the principles of responsible AI that can help you understand some of the challenges facing developers as they try to create ethical AI solutions.
I'm Chris. In Course 2, you will learn how to use Microsoft Azure Machine Learning to create and publish models without writing code. You'll also look at the Microsoft Azure services you can use to help ensure that your network is safe, secure, and trusted. Machine learning is at the core of artificial intelligence, and many modern applications and services depend on predictive machine learning models.
I'm Anita. In Course 3, you'll learn about how you can use computer vision to solve real-world problems. Computer vision is an area of artificial intelligence in which software systems are designed to perceive the world visually, through cameras, images, and video. There are multiple specific types of computer vision problems that AI engineers and data scientists can solve using a mix of custom machine learning models and platform-as-a-service solutions, including many cognitive services in Microsoft Azure.
I'm Donica. In Course 4, you'll explore some of the capabilities of natural language processing and conversational AI, and gain an understanding of how you might apply them to applications. Natural language processing supports applications that can see, hear, speak with, and understand users. Using text analytics, translation, and language understanding services, Microsoft Azure makes it easy to build applications that support natural language. Conversational AI is an artificial intelligence workload that deals with dialogues between AI agents and human users.
I'm David. Finally, in Course 5, you'll be given the opportunity to recap the key topics and concepts covered in each course, along with a practice exam. You'll also get tips and tricks, testing strategies, useful resources, and information on how to sign up for the AI 900 exam. Finally, you'll test your knowledge in a series of practice exams mapped to all the main topics covered in the AI 900 exam, ensuring you're well prepared for certification success.
Hello and welcome to this course, Artificial Intelligence on Microsoft Azure. This course is designed for anyone interested in learning about the types of solutions artificial intelligence, or AI, makes possible, and the services on Microsoft Azure that you can use to create them. With AI, you can build solutions that seemed like science fiction a short time ago, enabling incredible advances in healthcare, financial management, environmental protection, and other areas to make a better world for everyone. In this course, you'll be introduced to Microsoft Azure products and services that enable AI applications, including Azure Machine Learning, Azure Cognitive Services, and Azure Bot Services. Each option provides a diverse set of tools, services, and programmatic APIs. Some of the cognitive services APIs that you will be introduced to include vision APIs such as computer vision, custom vision, face and form recognizer, speech APIs such as speech service, language APIs such as Q&A maker and language understanding or LUIS, and decision APIs such as anomaly detector. You'll also learn that you can combine various Microsoft Azure services to create a perfect solution. In this course, you will explore the common uses of AI and the different types of associated workloads. You'll then work through the considerations and principles for responsible AI development. You'll start off by exploring AI workloads. In this lesson, you'll learn about the common uses of AI and the features of prediction or forecasting workloads, as well as features of anomaly detection and computer vision workloads. This lesson also covers how to identify natural language processing or knowledge mining, as well as conversational AI workloads. Next, you will work through guiding principles for responsible AI. You will learn about the considerations for fairness, reliability and safety, privacy and security, and inclusiveness in an AI solution. You'll also learn about considerations for transparency and accountability in an AI solution. Throughout this course, you'll have an opportunity to explore Microsoft Azure AI services through interactive exercises and real-world examples of AI in action, knowledge checks, and practice exams. We wish you every success as you start this exciting learning journey. Mastering AI fundamentals can help you jumpstart your career, whether you're new to the field or a seasoned professional, and prepare you to dive deeper into the many technical opportunities Microsoft Azure offers. As more businesses move to automate their processes and rely more heavily on AI processes, Microsoft Azure AI professionals will be among the most sought-after tech professionals in the coming years. Are you intrigued by this career field and wondering how to get started? Let's meet a few candidates and explore their career paths and how they got started. Jose lost his job during the COVID crisis. He had graduated with a bachelor's degree in history a few years ago. Jose has his sights set on becoming a solutions architect, specializing in AI and machine learning, and decides that achieving certification will open new career opportunities for him. A solutions architect is responsible for creating a comprehensive architecture for a software solution and providing strategic direction throughout the development process. The solutions architect works with all the teams involved in the development process. Jose is an ideal candidate, given the experience he has gathered as a cloud administrator and DevOps engineer. Jose completed the Microsoft certified Azure and Azure AI Fundamentals as a foundation for further studies. He went on to successfully complete the Microsoft certified Azure Administrator Associate and DevOps Engineer Expert certification pathway. Jose is currently completing the Microsoft certified Azure Solutions Architect Expert certification and landed a great job in this field. Letitia would like to advance her career. She graduated with a master's in computer science. Letitia has more than 5 years working as a software developer. Letitia wants to add new credentials to her portfolio and step beyond software or app development by moving into AI-managed services. Letitia is an ideal candidate for a role as a Microsoft Azure AI engineer. The work of an AI engineer involves a considerable focus on the analysis of requirements for AI solutions. Also, AI engineers provide recommendations for the appropriate tools and technologies for designing the solutions. As a Microsoft Azure AI engineer, Letitia will learn in collaboration with the data engineer, data scientist, AI developer, and IoT specialist to build complete end-to-end solutions. If this describes your workday, this could be the certification for you. Letitia completed the Microsoft certified Azure AI Fundamentals exam and went on to successfully complete the Microsoft certified Azure AI Engineer Associate certification pathway. Ingrid is looking for ways to advance in her existing career field and upskill in a competitive work environment. She has a master's in business administration and more than 5 years working as a project lead and manager in technology firms. She is familiar with the products and features available in the AI stacks from Google and AWS, but is looking to add foundational knowledge of AI services in Microsoft Azure. As a project manager, Ingrid works with people, processes, and technologies to continuously deliver business value. Ingrid successfully completed the AI 900 AI Fundamentals exam. She knows that the Microsoft certification has helped validate that she stays ahead with today's technology. She also knows that these studies have boosted her confidence and given her renewed job satisfaction. Ingrid works for a great company and may even be rewarded with a salary increase as she progresses. John is new to cloud services and works at an IT help desk. He has successfully completed the Microsoft certified Azure and Azure AI Fundamentals exams. John knows that one of the hottest roles in today's fast-paced IT environment is data scientist. These professionals are empowered by AI, machine learning, and data science. Data scientists analyze, process, and model data to help their organization visualize and deliver innovation, improve customer experience, grow the company's revenue, and stay ahead of the competition. If this describes you, your skill set, and your passion for data, Microsoft certified Azure Data Scientist Associate certification is an ideal choice. John specifically likes that a data scientist promotes a data-driven culture. Data scientists use rigorous scientific methodology and algorithms to discover and resolve business problems and to pursue opportunities to help achieve their organization's goals. John is a beginner but has already mapped out his career and certification path. With a view to getting ahead and completing the Microsoft certified Azure Data Scientist Associate certification, John is working hard at gaining the work experience he needs to succeed. Based on these scenarios, you can see that Microsoft provides you with the ability to start a specific certification path that matches your job role or career aspirations, while providing you the opportunity to improve your skills at the same time. There are different certification paths for you to choose from depending on your expertise and background. The certifications are structured into 3 expertise levels. The fundamentals certifications are targeted towards those just starting out with the technologies covered or looking to change careers. The associate certifications are targeted towards professionals that already have at least 2 years of practical experience working with the technologies covered. And the expert certifications are targeted towards professionals that have a minimum of 5 years advanced level practical experience and skills with the technologies covered. We have provided links to the various Microsoft certifications at the end of this lesson so that you can explore them in more detail. Microsoft Certified Azure AI Fundamentals certification is an opportunity to demonstrate knowledge of ML and AI workloads and how to implement them on Microsoft Azure. This certification is intended for candidates with both technical and non-technical backgrounds. Data science and software engineering experience are not required. However, some general programming knowledge or experience would be beneficial. Most Microsoft certification exams contain between 40 to 60 questions. However, the number can vary depending on the exam. There are different question types used during the exam, including scenarios, short answers, multiple choice, mark review, and drag and drop. Microsoft Azure AI Fundamentals can be used to prepare for other Microsoft Azure role-based certifications like Microsoft Certified Azure Data Scientist or AI Engineer Associate certification. The exam covers the following domain areas. Describe AI workloads and considerations. Describe fundamental principles of machine learning on Azure. Describe features of computer vision workloads on Azure. Describe features of natural language processing, or NLP, workloads on Azure, and describe features of conversational AI workloads on Azure. The higher the percentage, the more questions that specific section of the exam will contain. At this point, you may be wondering if you will have access to the information that you'll need to successfully pass the Microsoft Certified Azure AI Fundamentals exam. The answer is yes. Each domain area is mapped to this program. Once you successfully complete a course, you will be awarded a Coursera certificate. You will also receive a certificate on successful completion of this program. Next, you'll receive an electronic notification that allows you to unlock a 50% discount certification voucher code. Once you have unlocked the code, we encourage you to register and schedule the exam. You will be given directions on how to do this and how to prepare for the exam. Good luck with your preparation.
Hello, and my name is Chelsea Lee, and I am a Microsoft Technical Trainer. Welcome to Artificial Intelligence Fundamentals. What artificial intelligence is emulating some type of human capability. As humans, how do we learn? We learn through experiences as we're growing up. That data that we're collecting, that we're using to train our models, that's the data that we're providing our AI solutions, those experiences, to learn. And then from there, the sky's the limit, because we're collecting data on things that we would have never thought of before. And that's all data that can be used to build amazing AI solutions. AI has had a huge impact when it comes to software development or development in general. I mean, just let's think of, let's take, adding AI solutions to our applications, but let's just talk about testing or quality assurance, what we might know as QA. What's incredible about AI is we're able to test and, confirm our applications in a much faster rate than what was ever possible before, thanks to AI. And, from an application development side, it's now easier than ever to add artificial intelligence workloads to your development pipeline. Because before, you had to be a data scientist. You had to be able to build and train those machine learning models, and you had to develop and code and test and train your own AI workloads. But now, it's getting more and more accessible and easier to use. One of my favorite things about learning and working in artificial intelligence is reading all of the fantastic case studies. And if I think of, out of all the case studies that I've read of where AI was used, especially for good, has to be the AI that's really helping those who are visually impaired experience the world as someone with perfect vision. Whether it's using your phone to hold up to a menu and scanning that menu and saying, okay, I'm going to read the headers out loud. So is it the appetizers, the salads, the soups? Is it, maybe integrating into some glasses like the HoloLens or another pair of eyewear, where then there's a little speaker at the back. And so when they're looking at someone, one, it actually helps them adjust their eyes so that way they're actually making eye contact with the individual. And it's giving them, an age range. It's not perfect, but an estimate of what the age is. What emotion are they showing? What gender are they? If you're interested in getting started with a career in artificial intelligence, I would say you've already taken the perfect first step by enrolling and taking this course. Now, as you progress through your AI career, there's different areas where you might want to focus, and there's certain backgrounds that may be helpful. For example, if you have an experience like with coding or some type of computer science, Python is a really handy language to have when it comes to artificial intelligence. Now in this course, there are going to be some coding components, but don't worry, we have pre-scripted all of the coding for you, so all you're going to have to do is copy and paste. But I would say as you move along, it may be helpful to know how to maybe write some basic Python code as well as read and interpret it. Other areas of focus can be like physics or engineering or even robotics. Mathematics, there's a huge section of artificial intelligence specifically around machine learning that requires mathematics. So whether it's algebra or probability or statistics, all of those different areas are going to help you, as well as some cognitive science theory, and there's a few others as well. But what's really neat about artificial intelligence is it's always growing and changing and expanding. So even if you don't have a background in any of those things that I just mentioned, as long as you have the willingness to learn and to research and grow, you can definitely start your career in AI. If you're looking to start your career in artificial intelligence, I think one of the first things that you need to determine is, What path do you want to take? Do you want to work in machine learning, maybe as a data scientist? Do you want to work as a researcher collecting and analyzing the data? Do you want to work as a developer or even a business intelligence analyst? I mean, there's a couple different paths that you can take in artificial intelligence. Microsoft has created a number of different resources that are available for free to help you prepare for a career in artificial intelligence. This course that you're taking right now ties directly to the AI 900 course, which is our artificial intelligence fundamentals. And what's neat about that course is not only does it have a free learning path with a number of different labs and exercises that allow you to get familiar with some of the different machine learning and artificial intelligence services inside of Azure, but it's also tied to a certification. And this is a great way to showcase the skills and the knowledge that you obtained. So you can post this on your LinkedIn, share it with your professional network, and show people that you have started your career or you're learning new things inside of artificial intelligence.
Hello, and welcome to the world of AI. In this lesson, you'll explore how Microsoft Azure provides easy-to-use services to help you get started with building AI solutions. After completing this lesson, you will be able to identify features of prediction or forecasting workloads, identify features of anomaly detection workloads, identify computer vision workloads, identify natural language processing or knowledge mining workloads, and identify conversational AI workloads. So, what is AI? Simply put, AI is the creation of software that imitates human behaviors and capabilities. AI enables us to build amazing software that can improve healthcare, enable people to overcome physical disadvantages, empower smart infrastructure, create incredible entertainment experiences, and even save the planet. In the next video, you will see some more ways that AI can be used. Let's take a brief look at the key elements of AI. First, machine learning. This is often the foundation for an AI system and is the way we teach a computer model to make predictions and draw conclusions from data. Second, anomaly detection. This is the capability to automatically detect errors or unusual activity in a system. Third, computer vision. This is an area of AI in which software systems are designed to interpret the world visually through cameras, video, and images. Fourth, natural language processing enables a computer to interpret written or spoken language and respond in kind. And finally, conversational AI. Most commonly, conversational AI solutions use a software agent or bot to participate in conversation. Now, let's dive deeper into each of these key elements. Machine learning is the foundation for most AI solutions. Let's start by looking at a real-world example of how machine learning can be used to solve a difficult problem. So, how do machines learn? The answer is from data. In today's world, we create huge volumes of data as we go about our everyday lives. From the text messages, emails, and social media posts we send, to the photographs and videos we take on our phones, we generate massive amounts of information. More data still is created by millions of sensors in our homes, cars, cities, public transport infrastructure, and factories. Data scientists can use all of this data to train machine learning models that can make predictions and inferences based on the relationships they find in the data. Now, let's explore a scenario. Suppose an environmental conservation organisation wants volunteers to identify and catalogue different species of wildflower using a phone app. Let's take a look at how machine learning can work for this scenario. First, a team of botanists and data scientists collect samples of wildflowers. Second, the team labels the samples with the correct species. Next, the labelled data is processed using an algorithm that finds relationships between the features of the samples and the labelled species. Then, the results of the algorithm are encapsulated in a model. And finally, when new samples are found by volunteers, the model can identify the correct species label. Microsoft Azure provides the Azure Machine Learning Service, a cloud-based platform for creating, managing, and publishing machine learning models. Let's review some features and capabilities provided by Azure Machine Learning. First, automated machine learning. This feature enables non-experts to quickly create an effective machine learning model from data. Second, Azure Machine Learning Designer. This is a graphical interface enabling no-code development of machine learning solutions. Third, data and compute management. This feature provides cloud-based data storage and compute resources that professional data scientists can use to run data experiment code at scale. And finally, pipelines. This allows data scientists, software engineers, and IT operations professionals to define pipelines to orchestrate model training, deployment, and management tasks. Let's look at a real-world example of AI in action. Sustainable farming techniques are essential to maximize food production while protecting a fragile environment. The Yield, an agricultural technology company based in Australia, uses sensors, data and machine learning to help farmers make informed decisions related to weather, soil and plant conditions. You can learn about how they do this in the next video. Imagine you're creating a software system to monitor credit card transactions and detect unusual usage patterns that might indicate fraud. Or an application that tracks activity in an automated production line and identifies failures. Or a racing car telemetry system that uses sensors to proactively warn engineers about potential mechanical failures before they happen. These types of scenario can be addressed by using anomaly detection, a machine learning-based technique that analyzes data over time and identifies unusual changes. Let's explore how anomaly detection might help in the racing car scenario. To start with, sensors in the car collect telemetry, such as engine revolutions, brake temperature, and so on. Next, an anomaly detection model is trained to understand expected fluctuations in the telemetry measurements over time. At this point, if a measurement occurs outside of the normal expected range, the model reports an anomaly that can be used to alert the race engineer to call the driver in for a pit stop to fix the issue before it forces retirement from the race. In Microsoft Azure, the Anomaly Detector service provides an application programming interface, or API, that developers can use to create anomaly detection solutions. Computer vision is an area of AI that deals with visual processing. Let's explore some of the possibilities that computer vision brings. The Seeing AI app is a great example of the power of computer vision. Designed for the blind and low vision community, the Seeing AI app harnesses the power of AI to open up the visual world and describe nearby people, text, and objects. To find out more, check out the Seeing AI webpage or use the link at the end of this lesson. Most computer vision solutions are based on machine learning models that can be applied to visual input from cameras, videos, or images. Let's review some common computer vision tasks. Image classification involves training a machine learning model to classify images based on their contents. For example, in a traffic monitoring solution, you might use an image classification model to classify images based on the type of vehicle they contain, such as taxis, buses, cyclists, and so on. Object detection machine learning models are trained to classify individual objects within an image and identify their location with a bounding box. In this example, the traffic monitoring solution uses object detection to identify the location of different classes of vehicle. Semantic segmentation is an advanced machine learning technique in which individual pixels in the image are classified according to the object to which they belong. This image represents a traffic monitoring solution that overlays traffic images with mask layers to highlight different vehicles using specific colors. You can create solutions that combine machine learning models with advanced image analysis techniques to extract information from images, including tags that could help catalog the image, or even create descriptive captions that summarize the scene shown in an image. Face detection is a specialized form of object detection that locates human faces in an image. This can be combined with classification and facial geometry analysis techniques to infer details such as age and emotional state, and even recognize individuals based on their facial features. Optical character recognition is a technique used to detect and read text in images. You can use OCR to read text in photographs, for example road signs or storefronts, or to extract information from scanned documents such as letters, invoices, or forms. Form processing lets you read and save information from standard documents, such as invoices or tax documents. When you automate this process, you can save valuable time by reviewing, extracting, organizing, and saving the data automatically. Microsoft Azure provides cognitive services to help you create computer vision solutions. Let's briefly review these services. you can use Microsoft Azure's computer vision service to analyze images and video and extract descriptions, tags, objects, and text. On the other hand, you can use the Custom Vision service to train custom image classification and object detection models using your own images. If you need to build face detection and facial recognition solutions, you can use the Face service. In addition, you can use Form Recognizer to extract information from scanned forms and invoices. Natural Language Processing, or NLP, is the area of AI that deals with creating software that understands written and spoken language. NLP enables you to create software that can analyze and interpret text in documents, email messages, and other sources, interpret spoken language and synthesize speech responses, automatically translate spoken or written phrases between languages, and interpret commands and determine appropriate actions. Microsoft Azure provides cognitive services to help you build NLP solutions. Let's briefly review these services. You can use Microsoft Azure's Text Analytics service to analyze text documents and extract key phrases, detect entities such as places, dates, and people, and evaluate sentiment to determine how positive or negative a document is. On the other hand, you can use the Translate Text service to translate text between more than 60 languages. If you need to recognize and synthesize speech and to translate spoken languages, you can use the Speech service. In addition, you can use Language Understanding Intelligence Service, or LUIS, to train a language model that can understand spoken or text-based command. An example of Microsoft Azure's NLP in action is Starship Commander, a virtual reality game from Human Interact that takes place in a science fiction world. The game uses NLP to enable players to control the narrative and interact with in-game characters and starship systems. Conversational AI is the term used to describe solutions where AI agents participate in conversations with humans. Most commonly, conversational AI solutions use bots to manage dialogues with users. Apart from providing good customer support for products and services, bots can be the basis of various AI solutions, including reservation systems for restaurants, airlines, cinemas, and other appointment-based businesses, healthcare consultations and self-diagnosis, and home automation and personal digital assistants. You can create conversational AI solutions on Microsoft Azure using Q&A Maker and Azure Bot Service. Q&A Maker is a cognitive service that enables you to quickly build a knowledge base of questions and answers that can form the basis of a dialogue between a human and an AI agent. Azure Bot Service provides a platform for creating, publishing, and managing bots. Developers can use the bot framework to create a bot and manage it with Azure Bot Service, integrating back-end services like Q&A Maker and LUIS, and connecting to channels for web chat, email, Microsoft Teams, and others. Welcome back. In this lesson, you'll explore considerations and principles for responsible AI development. Artificial intelligence is a powerful tool that can be used to greatly benefit the world. However, like any tool, it must be used responsibly. At Microsoft, AI software development is guided by a set of 6 principles: fairness, reliability and safety, privacy and security, inclusiveness, transparency, and accountability. These principles are designed to ensure that AI applications provide amazing solutions to difficult problems without any unintended negative consequences. Let's dive right in and explore the 6 guiding principles of responsible AI development. First, AI systems should treat all people fairly. Suppose you create a machine learning model to support a loan approval application for a bank. The model should make predictions of whether or not the loan should be approved without incorporating any bias based on gender, ethnicity, or other factors that might result in an unfair advantage or disadvantage to specific groups of applicants. Microsoft Azure Machine Learning includes the capability to interpret models and quantify the extent to which each feature of the data influences the model's prediction. This capability helps data scientists and developers identify and mitigate bias in the model. Second, AI systems should perform reliably and safely. Consider an AI-based software system for an autonomous vehicle, or a machine learning model that diagnoses patient symptoms and recommends prescriptions. Unreliability in these kinds of systems can result in substantial risk to human life. AI-based software application development must be subjected to rigorous testing and deployment management processes to ensure that they work as expected before release. Third, AI systems should be secure and respect privacy. The machine learning models on which AI systems are based rely on large volumes of data, which may contain personal details that must be kept private. Even after the models are trained and the system is in production, it uses new data to make predictions or take action that may be subject to privacy or security concerns. Next, AI systems should empower everyone and engage people. AI should bring benefits to all parts of society, regardless of physical ability, gender, sexual orientation, ethnicity, or other factors. Furthermore, AI systems should be understandable. Users should be made fully aware of the purpose of the system, how it works, and what limitations may be expected. Finally, people should be accountable for AI systems. Designers and developers of AI-based solutions should work within a framework of governance and organizational principles that ensure the solutions meet ethical and legal standards that are clearly defined. Now, you have an opportunity to further explore these principles as you continue with this lesson. Congratulations! You have completed this course. To start with, you covered the key elements of AI: features of prediction or forecasting, features of anomaly detection, computer vision, natural language processing, and conversational AI. Next, you explored the guiding principles and considerations for responsible AI development. These include considerations for fairness, reliability and safety, privacy and security, inclusiveness, transparency, and accountability in an AI solution. Demonstrating knowledge of these topics is a requirement in the AI 900 Microsoft Azure AI Fundamentals exam. You are one step further down the road to certification. You can find more resources to help you put the responsible AI principles into practice on Microsoft's AI website.
Hello and welcome. This course aims to help you learn how to use Microsoft Azure Machine Learning to create and publish machine learning models without writing code. Microsoft Azure Machine Learning is a cloud-based service with a wide range of features and capabilities that help data scientists prepare data, train models, publish predictive services, and monitor their usage. In this course, you'll explore the following lessons: Microsoft Azure Machine Learning to train and deploy a predictive model, create a regression model, create a classification model, and create a clustering model with Azure AI. You'll also work through a number of practical exercises. On completing the exercises, you'll be able to create no-code predictive models with Azure Machine Learning. This hands-on approach will help you in your preparation for the AI 900 exam. To complete the practical exercises, you will make use of an Azure Machine Learning workspace. You can then use this workspace to manage data, compute resources, code, models, and other artifacts related to your machine learning workloads. To use Azure Machine Learning, you create a workspace in your Microsoft Azure subscription. If you don't already have an Azure subscription, you can sign up for a free trial by accessing the Microsoft Azure webpage or using the link provided. You'll also find more detail on how to create an Azure subscription later in this course. After completing each set of practical exercises in a lesson, be sure to follow the cleanup instructions to stop the compute instance until you need it again. You'll have access to the process on how to clean up at the end of each lesson. You'll also have an opportunity to complete knowledge checks that will keep you on track and let you know how you are doing and what you have learned so far, and test prep questions which you can use to check your progress and prepare effectively for the AI 900 exam. Once you successfully complete this course, you'll be awarded a Coursera certificate. Good luck with your preparation. Welcome. In this lesson, we will look at how to train and deploy a predictive model in Microsoft Azure Machine Learning. After completing this lesson, you will be able to identify different types of machine learning models and use the automated machine learning capability of Azure Machine Learning to train and deploy a predictive model. What is machine learning? Machine learning is a technique that uses mathematics and statistics to create a model that can predict unknown values. It is the foundation for most artificial intelligence solutions. The creation of an artificially intelligent solution often begins with the use of machine learning to train a predictive model using historic data that you have collected. Training and deploying an effective machine learning model involves a lot of work. It can be a time-consuming and resource-intensive process. Azure Machine Learning is a cloud-based service with a wide range of features and capabilities that help data scientists to prepare data, train models, publish predictive services, and monitor their usage. Most importantly, it helps data scientists increase their efficiency by automating many of the time-consuming tasks associated with training models. Azure Machine Learning also enables the use of cloud-based compute resources that scale effectively to handle large volumes of data. With this cloud-based service, you pay only for the Azure Machine Learning resources that you use. To create an artificially intelligent solution, you often begin by using machine learning to train a predictive model using historic data. For example, suppose Adventure Work Cycles is a business that rents bicycles. To ensure that sufficient staff and bicycles are always available, the business could use historic data to train a model that predicts daily rental demand. To do this, the business could create a machine learning model that takes information about a specific day, the day of the week, the anticipated weather conditions, and so on, as an input. The model then predicts the expected number of rentals as an output. Later, you will see more about how Adventure Work Cycles could use a machine learning model. In the rest of this lesson, you'll explore Azure Machine Learning and in particular, its automated machine learning capability. Be sure to check out the next video which discusses the various types of machine learning model you can create and the process generally followed to train and use them. Congratulations! You've completed this lesson on Microsoft Azure Machine Learning to train and deploy a predictive model. In this lesson, you explored machine learning, identified different types of machine learning model, and learned how to use the automated machine learning capabilities of Azure Machine Learning to train and deploy a predictive model. Don't forget to do your end of lesson cleanup. The web service you created during the practical sessions is hosted in an Azure container instance. If you don't intend to experiment with it further, you should delete the endpoint to avoid accruing unnecessary Azure usage. You should also stop the training cluster and the compute instance resources until you need them again. You will find step-by-step cleanup instructions elsewhere in this lesson. Hello and welcome. In this lesson, you'll learn how to train and publish a regression model with Microsoft Azure Machine Learning Designer without needing to write any code. By the end of this lesson, you'll be able to use Azure Machine Learning Designer to train a regression model, use a regression model for inferencing, and deploy a regression model as a service. Earlier in this course, you explored machine learning. Machine learning uses algorithms to identify patterns within data, and those patterns are then used to create a data model that can make predictions. Regression is a form of machine learning that is used to predict a numeric label based on an item's features. For example, an automobile sales company might use the characteristics of an auto, such as engine size, number of seats, mileage, and so on, to predict its likely selling price. In this case, the characteristics of the car, the features, and the selling price is the label. Regression is an example of a supervised machine learning technique in which you train a model using data. The data includes both the features and known values for the label, so that the model learns to fit the feature combinations to the label. Then after training has been completed, you can use the trained model to predict labels for new items for which the label is unknown. You can use Microsoft Azure Machine Learning Designer to create regression models by using a drag-and-drop visual interface without needing to write any code. Congratulations, you completed this lesson. Let's look at some of the key elements you explored in this lesson. First, you learned how to use Microsoft Azure Machine Learning Designer to train a regression model by creating a pipeline. After creating and running a pipeline to train the model, you use the trained model to inference, in other words predict, label values based on its features. Lastly, you practice deploying and testing a predictive service. Once you've completed all the practical exercises in this lesson, please remember to clean up. If you don't intend to experiment any further, you should delete the endpoint to avoid accruing unnecessary Azure usage. And you should also stop the compute instance until you need it again. You can access the detailed process in the reading on cleanup. Welcome to this lesson where you will create a classification model with Microsoft Azure Machine Learning Designer. After completing this lesson, you'll be able to use Azure Machine Learning Designer to train a classification model, use a classification model for inferencing, and deploy a classification model as a service. What is classification? Classification is a form of machine learning that is used to predict which category or class an item belongs to. For example, a health clinic might use the characteristics of a patient, such as age, weight, blood pressure, and so on, to predict whether the patient is at risk of diabetes. In this case, the characteristics of the patient are the features, and the label is a classification of either 0 or 1, representing non-diabetic or diabetic. Classification is an example of a supervised machine learning technique in which you train a model using data that includes both the features and known values for the label. With classification, the model learns to fit the feature combinations to the label. In our health clinic example, measurements such as weight, height, glucose level, blood pressure, and so on are collected for each patient. These are the features, represented by X in our equation. We also know if the patient we are measuring is diabetic or not. That label, Y, is a classification of the patient. In this case, the class is whether the patient is diabetic or not diabetic. When training is completed, you can use the trained model to predict labels for new items for which the label is unknown. When measurements of a new patient are taken, the trained model uses those features to predict the probability of the patient being diabetic or not diabetic. You can use Microsoft Azure Machine Learning Designer to create classification models by using a drag and drop visual interface without needing to write any code. To complete this module, you'll need to use your Microsoft Azure subscription. Congratulations, you've completed this lesson. In this lesson, you trained and published a classification model with Azure Machine Learning Designer. Don't forget to do your end of lesson cleanup. The web service you created during the practical sessions is hosted in an Azure container instance. If you don't intend to experiment with it further, you should delete the endpoint to avoid accruing unnecessary Azure usage. You should also stop the training cluster and the compute instance resources until you need them again. Full cleanup instructions are shown earlier. Hello and welcome. In this lesson, you'll learn how to train and publish a clustering model with Microsoft Azure Machine Learning Designer without needing to write any code. By the end of this lesson, you'll be able to use Azure Machine Learning Designer to train a clustering model, use a clustering model for inferencing, and deploy a clustering model as a service. Clustering is a form of machine learning that is used to group similar items into clusters based on their features. For example, a researcher might take measurements of penguins and group them based on similarities in their proportions. In Microsoft Azure Machine Learning, data for model training and other operations is usually encapsulated in an object called a dataset. In this lesson, you'll use a dataset that includes observations of 3 species of penguin. Earlier in this course, you explored regression, which is an example of a supervised machine learning technique. Using this technique, you trained a model using data that includes both the features and known values for the label. In this lesson, you'll focus on unsupervised machine learning. Clustering is an example of unsupervised machine learning, in which you train a model to separate items into clusters based purely on their characteristics or features. There is no previously known cluster value or label from which to train the model. You can use Azure Machine Learning Designer to create clustering models by using a drag and drop visual interface without needing to write any code. Congratulations! You've completed the final lesson in this course. Please remember to clean up. If you don't intend to experiment any further, you should delete the endpoint to avoid accruing unnecessary Azure usage. And you should also stop the compute instance until you need it again. You can access the process in the reading on cleanup. In this course, you explored some fundamental machine learning concepts and used the automated machine learning capabilities of Microsoft Azure Machine Learning to train and deploy a predictive model. You also gained hands-on experience on how to use Azure Machine Learning Designer and Azure Machine Learning Studio to train, use, and deploy a regression, classification, and clustering model. You are one step further down the road to certification. Microsoft Azure certifications validate the skills and knowledge that you demonstrate. Successfully completing this program can help you to develop your career goals as well as open up further career opportunities.
Hello and welcome. In this course, you'll explore computer vision in Microsoft Azure. Microsoft Azure provides cognitive services to help you create computer vision solutions. You'll explore 2 cognitive services. You will see the computer vision service. This service includes Form Recognizer to extract key value pairs and tables from documents, and Face to detect and recognize faces in images. And you will look at the Custom Vision service, which helps you to train custom image classification and object detection models using your own images. In this course, you'll learn how to use the Computer Vision Cognitive Service to analyze images, use the Custom Vision Service to create an image classification solution, use the Custom Vision Service to create an object detection solution, use the Face Cognitive Service to detect and analyze faces in images, read text in images with a Computer Vision Service, and use the built-in receipt processing capabilities of the Form Recognizer service. The best way to learn is to explore. You'll work through a number of practical exercises. To complete the practical exercises, you will make use of a virtual lab environment. You'll be provided with the guidance you need to access the labs at the start of each exercise. To complete the practical exercises, you'll need an Azure subscription.
If you don't already have an Azure subscription, you can sign up for a free trial by accessing the Microsoft Azure webpage or using the link provided. You'll find more detail on how to create an Azure subscription later in this course. You'll also have an opportunity to complete interactive exercises that give you the opportunity to gain hands-on experience, knowledge checks that will keep you on track and let you know how you're doing and what you have learned so far, and test prep questions, which you can use to check your progress. This hands-on approach will help you in your preparation for the AI 900 exam. Once you successfully complete this course, you'll be awarded a Coursera certificate. Good luck with your preparation. Welcome. In this lesson, we will look at using computer vision service to analyze images in Microsoft Azure. The computer vision service enables software engineers to create intelligent solutions that extract information from images, a common task in many artificial intelligence or AI scenarios. After completing this lesson, you will be able to use the computer vision cognitive service to analyze images. Computer vision is one of the core areas of artificial intelligence. It focuses on creating solutions that enable AI-enabled applications to see the world and make sense of it. Of course, computers don't have biological eyes that work the way ours do, but they are capable of processing images, either from a live camera feed or from digital photographs or videos. This ability to process images is the key to creating software that can emulate human visual perception. To an AI application, an image is just an array of pixel values. These numeric values can be used as features to train machine learning models that make predictions about the image and its contents. In Microsoft Azure, the computer vision cognitive service uses pre-trained models to analyze images, enabling software developers to easily build applications that can interpret an image and suggest an appropriate caption, suggest relevant tags that could be used to index an image, categorize an image, identify objects in an image, detect faces and people in an image, recognize celebrities and landmarks in an image, and read text in an image. You'll explore some of these capabilities as you learn to use the computer vision service to analyze images. Let's get started with image analysis on Azure. The computer vision service is a cognitive service in Microsoft Azure that provides pre-built computer vision capabilities. The service can analyze images and return detailed information about an image and the objects it depicts. To use the computer vision service, you need to create a resource for it in your Azure subscription. You can use either of the following resource types. Computer vision, a specific resource for the computer vision service. Use this resource type if you don't intend to use any other cognitive services, or if you want to track utilization and costs for your computer vision resource separately. Cognitive services, a general cognitive services resource that includes computer vision along with many other cognitive services, such as text analytics, translator text, and others. Use this resource type if you plan to use multiple cognitive services and want to simplify administration and development. Whichever type of resource you choose to create, to use it, you will need two pieces of information: a key that is used to authenticate client applications, and an endpoint that provides the HTTP address at which your resource can be accessed. If you create a cognitive services resource, client applications use the same key and endpoint, regardless of the specific service they are using. After you've created a suitable resource in your subscription, you can submit images to the computer vision service to perform a wide range of analytical tasks. Computer vision has the ability to analyze an image, evaluate the objects that are detected, and generate a human-readable phrase or sentence that describes what was detected in the image. Depending on the image contents, the service may return multiple results or phrases. Each returned phrase will have an associated confidence score, indicating how confident the algorithm is in the supplied description. The highest confidence phrases will be listed first. To help you understand this concept, consider this image of the Empire State Building in New York. In the order of confidence, the returned phrases are: a black and white photo of a city, a black and white photo of a large city, a large white building in a city. The image descriptions generated by computer vision are based on a set of thousands of recognizable objects, which can be used to suggest tags for the image. These tags can be associated with the image as metadata that summarizes attributes of the image and can be particularly useful if you want to index an image along with a set of key terms that might be used to search for images with specific attributes or contents. For example, the tags returned for the Empire State Building image include skyscraper, tower, and building. The object detection capability is similar to tagging in that the service can identify common objects, but rather than tagging or providing tags for the recognized objects only, this service can also return what is known as bounding box coordinates. With object detection, not only will you get the type of object, but you will also receive a set of coordinates that indicate the top, left, width, and height of the object detected, which you can use to identify the location of the object in the image. This feature provides the ability to identify commercial brands. The service has a database of thousands of globally recognized logos from commercial brands and products. When you call the service and pass it an image, it performs a detection task and determines if any of the identified objects in the image are recognized brands. The service compares the brands against its database of popular brands, including clothing, consumer electronics, and many more categories. If a known brand is detected, the service returns a response that contains the brand name and a confidence score from 0 to 1, indicating how positive the identification is, and a bounding box with coordinates showing where in the image the detected brand was found. For example, the image of a laptop has a Microsoft logo on its lid, which is identified and located by the computer vision service. The computer vision service can detect and analyze human faces in an image, including the ability to determine age and a bounding box rectangle for the location of the face or faces. The facial analysis capabilities of the computer vision service are a subset of those provided by the dedicated face service. If you need basic face detection and analysis combined with general image analysis capabilities, use the computer vision service. But for more comprehensive facial analysis and facial recognition functionality, use the face service. Here you see an image of a person with their face detected and an approximate age estimated. Computer vision can categorize images based on their contents. The service uses a parent-child hierarchy with a current limited set of categories. When analyzing an image, detected objects are compared to the existing categories to determine the best way to provide the categorization. As an example, one of the parent categories is people. This image of a woman on a roof is assigned a category of people. A slightly different categorization is returned for this image, which is assigned to the category people_group, because there are multiple people in the image. You can review the complete categorization list, Computer Vision Category Taxonomy. The URL is listed in additional resources. When categorizing an image, the computer vision service supports two specialized domain models. Celebrities. The service includes a model that has been trained to identify thousands of well-known celebrities from sport, entertainment, and business. And landmarks. The service can identify famous landmarks such as the Taj Mahal and the Statue of Liberty. For example, when analyzing this image for landmarks, the computer vision service identifies the Eiffel Tower with a confidence of 99.41%. The computer vision service can use optical character recognition, or OCR, capabilities to detect printed and handwritten text and images. The OCR capability is explored later in this course. In addition to these capabilities, the computer vision service can also detect image types, for example, identifying clip art images or line drawings. Detect image color schemes, determining whether an image is black and white or color, and identifying the dominant foreground, background, and overall colors in color images. Generate thumbnails, creating small versions of images, and moderate content, detecting images that contain adult content or depict violent, gory scenes. Be sure to complete this lesson's exercises to get practical hands-on experience of the computer vision service. Welcome. In this lesson, we will look at using the custom vision service to perform image classification. After completing this lesson, you will be able to use the custom vision service to analyze images. You are going to look at image classification, but first, take a quick look at what classification itself means. Classification is a machine learning technique that you can use to predict which category or class something belongs to. Classification machine learning models use a set of inputs, which we call features, to calculate a probability score for each possible class and predict a label that indicates the most likely class that an object belongs to. For example, the features of a flower might include the measurements of its petals, stem, sepals, and other quantifiable characteristics. A machine learning model could be trained by applying an algorithm to these measurements that calculates the most likely species of the flower, its class. To create a classification model, you need data that consists of features for which the labels are already known. You use this to train the model so that it determines a relationship between the features and the corresponding label. Then, after the model has been trained, you can use it with new sets of features to predict unknown label values. To summarize our definition of classification, it is a machine learning technique that is used to train a model so that when the model encounters a new value that does not have a class, it is able to classify it correctly. Image classification is a machine learning technique in which the object being classified is an image, such as a photograph. As with any form of classification, creating an image classification solution involves training a machine learning model using a set of existing data for which the class is already known. In this case, the existing data consists of a set of categorized images. Digital images are made up of an array of pixel values, and these are used as features to train the model based on the known image classes. Most modern image classification solutions are based on deep learning techniques that make use of convolutional neural networks, or CNNs, to uncover patterns in the pixels that correspond to particular classes. Training an effective CNN is a complex task that requires considerable expertise in data science and machine learning. However, in Microsoft Azure, common techniques used to train image classification models have been encapsulated into the Custom Vision Cognitive Service, making it easy to train a model and publish it as a software service with minimal knowledge of deep learning techniques. Some potential uses for image classification might include product identification, performing visual searches for specific products in online searches, or even searching in-store using a mobile device. Disaster investigation, evaluating key infrastructure for major disaster preparation efforts. For example, aerial surveillance images may show bridges and classify them as such. Anything classified as a bridge could then be marked for emergency preparation and investigation. Medical diagnosis. Evaluating images from X-ray or MRI devices could quickly classify specific issues found as cancerous tumors or many other medical conditions related to medical imaging diagnosis. Let's get started with image classification on Azure. You can perform image classification using the Custom Vision service, available as part of the Azure Cognitive Services offerings. This is generally easier and quicker than writing your own model training code, and it enables people with little or no machine learning expertise to create an effective image classification solution. Creating an image classification solution with Custom Vision consists of two main tasks. First, you must use existing images to train the model, and then you must publish the model so that client applications can use it to generate predictions. For each of these tasks, you need a resource in your Azure subscription. You can use the following types of resource. Custom Vision, a dedicated resource for the Custom Vision service, which can be training, a prediction, or both resources. Cognitive Services, a general cognitive services resource that includes Custom Vision along with many other cognitive services. You can use this type of resource for training, prediction, or both. The separation of training and prediction resources is useful when you want to track resource utilization for model training separately from client applications using the model to predict image classes. However, it can make development of an image classification solution a little confusing. The simplest approach is to use a general cognitive services resource for both training and prediction. This means you only need to concern yourself with one endpoint, the HTTP address at which your service is hosted, and key, a secret value used by client applications to authenticate themselves. If you choose to create a Custom Vision resource, you will be prompted to choose training, prediction, or both. And it's important to note that if you choose both, then two resources are created, one for training and one for prediction. It's also possible to take a mix and match approach in which you use a dedicated Custom Vision resource for training, but deploy your model to a cognitive services resource for prediction. For this to work, the training and prediction resources must be created in the same region. To train a classification model, you must upload images to your training resource and label them with the appropriate class labels. Then, you must train the model and evaluate the training results. You can perform these tasks in the Custom Vision portal, or if you have the necessary coding experience, you can use one of the Custom Vision Service Programming language-specific software development kits, or SDKs. One of the key considerations when using images for classification is to ensure that you have sufficient images of the objects in question, and those images should be of the object from many different angles. Model training is an iterative process in which the Custom Vision service repeatedly trains the model using some of the data, but holds back a portion of the data to use for evaluation of the model. At the end of the training process, the performance for the trained model is indicated by the following evaluation metrics. Precision. What percentage of the class predictions made by the model were correct? For example, if the model predicted that 10 images are oranges, of which 8 were actually oranges, then the precision is 0.8, or 80%. Recall. What percentage of class predictions did the model correctly identify? For example, if there are 10 images of apples and the model found 7 of them, then the recall is 0.7, or 70%. Average precision, an overall metric that takes into account both precision and recall. After you've trained the model and you're satisfied with its evaluated performance, you can publish the model to your prediction resource. When you publish the model, you can assign it a name. The default is iteration X, where X is the number of times you have trained the model. To use your model, client application developers need the following information. Project ID, the unique ID of the Custom Vision project you created to train the model. Model name, the name you assigned to the model during publishing. Prediction endpoint, the HTTP address of the endpoints for the prediction resource to which you publish the model, not the training resource. Prediction key, the authentication key for the prediction resource to which you publish the model, not the training resource.
Great job and well done. You learned how to use the Custom Vision service to perform image classification. Image classification is used to assign images to categories or classes. Patterns and image pixel values are used to determine which class a particular image belongs, and a model is trained to match the patterns in the pixel values to a set of class labels. You can use the Custom Vision cognitive service to train image classification models and deploy them as services for applications to use. The computer vision service provides many capabilities that you can use to analyze images, including generating a descriptive caption, extracting relevant tags, identifying objects, determining image type and metadata, detecting human faces, known brands and celebrities, and others. As you continue your learning journey, remember, mastering Microsoft AI fundamentals can help you to develop your career goals as well as open up further learning and career opportunities.
Hello and welcome. In this lesson, you'll learn how to use the Custom Vision service on Microsoft Azure to create an object detection solution. Object detection is a form of machine learning-based computer vision in which a model is trained to classify individual objects within an image and identify their location with a bounding box. Custom Vision functionality can be divided into two features, object detection and image classification. So what's the difference between these two techniques? Image classification is a machine learning technique in which a model is trained to categorize images based on the primary subject matter they contain. Object detection goes further than this, to classify individual objects within the image and to return the coordinates of a bounding box that indicates the object's location. For example, imagine a model has been trained to detect apples, bananas, and oranges. When provided an image, it will output a set number of detection results. In this image, the object detection model returns the following information: the class of each object identified in the image, the probability score of the object classification, which you can interpret as the confidence of the predicted class being correct, and the coordinates of a bounding box for each object in the image. Object detection is used in a wide range of industries. Sample applications include evaluating the safety of a building by looking for fire extinguishers or other emergency equipment, creating software for self-driving cars or vehicles with lane assist capabilities, and medical imaging, such as an MRI or X-rays, that can detect known objects for medical diagnosis. You can create an object detection machine learning model by using advanced deep learning techniques. However, this approach requires significant expertise and a large volume of training data. The Custom Vision Cognitive Service in Microsoft Azure enables you to create object detection models that meet the needs of many computer vision scenarios with minimal deep learning expertise and fewer training images. Let's take a look at the tasks that you perform to create your custom machine learning, or ML, model. Creating an object detection solution with Microsoft Azure's Custom Vision service consists of 3 main tasks. First, you must upload images and tag them. Then, you can train the model based on the tagged and uploaded images. And finally, you must publish the trained model. Once the model is published, it can be used to generate predictions. For each of these tasks, you need a resource in your Microsoft Azure subscription. The Custom Vision service allows you to build an object detection model in one of 2 ways. You have the choice of using either a Custom Vision resource, a dedicated resource for the Custom Vision service, which can be either a training or a prediction resource, or a cognitive services resource, a general cognitive services resource that includes Custom Vision along with many other cognitive services. You can use this type of resource for training, prediction, or both. Let's explore these options a little further. The separation of training and prediction resources is useful when you want to track resource utilization for model training separately when using the model to predict image classes. However, the separation of training and prediction resources can make development of an image classification solution a little confusing. The choice you make depends on how you plan to architect your solution. If you only want a service that will cover the training and use of your ML model, then using the dedicated Custom Vision resource is the best choice. This option allows you to use either training or prediction, but not both. However, if you need a resource that, for example, provides the option to train a custom vision model and also create a pre-built image classification, then using a general cognitive service resource for both training and prediction is the simplest approach. This means you only need to concern yourself with one endpoint, the HTTP address at which your service is hosted, and key, a secret value used by client applications to authenticate themselves. If you choose to create a custom vision resource, you will be prompted to choose training, prediction, or both. And it's important to note that if you choose both, then 2 resources are created, one for training and one for prediction. It's also possible to take a mix and match approach in which you use a dedicated custom vision resource for training, but deploy your model to a cognitive services resource for prediction. For this to work, the training and prediction resources must be created in the same region. Before you can train an object detection model, you must tag the classes and bounding box coordinates in a set of training images. The interface will automatically suggest areas of the image where discrete objects are detected, and you can apply a class label to these suggested bounding boxes or drag to adjust the bounding box area. This process can be time-consuming, but the Custom Vision portal provides a graphical interface that makes it straightforward. Additionally, after tagging and training with an initial dataset, the Computer Vision service can use smart tagging to suggest classes and bounding boxes for images you add to the training dataset. Key considerations when tagging training images for object detection are ensuring that you have sufficient images of the objects in question, preferably from multiple angles, and making sure that the bounding boxes are defined tightly around each object. To train the model, you can use the Custom Vision portal, or if you have the necessary coding experience, you can use one of the Custom Vision service programming language-specific software development kits, SDKs. Training an object detection model can take time, depending on the number of training images, classes, and objects within each image. Model training is an iterative process in which the Custom Vision service repeatedly trains the model using some of the data, but holds some back to evaluate the model. At the end of the training process, the performance for the trained model is indicated by the following evaluation metrics. Precision. What percentage of class predictions did the model correctly identify? For example, if the model predicted that 10 images are oranges, of which 8 were actually oranges, then the precision is 0.8, or 80%. Recall. What percentage of the class predictions made by the model were correct? For example, if there are 10 images of apples and the model found 10 of them, then the recall is 1, or 100%. And mean average precision, an overall metric that takes into account both precision and recall across all classes. After you've trained the model and you're satisfied with its evaluated performance, you can publish the model to your prediction resource. When you publish the model, you can assign it a name. The default is iteration X, where X is the number of times you have trained the model. To use your model, client application developers need the following information: project ID, the unique ID of the custom vision project you created to train the model; model name, the name you assigned to the model during publishing; prediction endpoint, the HTTP address of the endpoints for the prediction resource to which you publish the model, not the training resource; and prediction key, the authentication key for the prediction resource to which you publish the model, not the training resource. Great job and well done. You learned how to use the Custom Vision service to create an object detection solution. You worked through object detection on Microsoft Azure, Azure resources for custom vision, image tagging, model training and evaluation, and how to use the model for prediction. Detecting objects and images has proven a key element in many applications that help improve safety, provide better medical imaging diagnostics, manage stock levels for inventory management, and even help preserve wildlife. The object detection capabilities in the Custom Vision service makes it easy to develop models that support these kinds of scenarios. As you continue your learning journey, remember, mastering Microsoft AI fundamentals can help you to develop your career goals as well as open up further learning and career opportunities. Hello and welcome. In this lesson, you'll learn how to use the Face Cognitive Service to detect and analyze faces in images. Face detection and analysis is an area of artificial intelligence, or AI, in which you use algorithms to locate and analyze human faces in images or video content. Face detection involves identifying regions of an image that contain a human face, typically by returning bounding box coordinates that form a rectangle around the face, as in this image. Moving beyond simple face detection, some algorithms can also return other information, such as facial landmarks, for example, nose, eyes, eyebrows, and lips. These facial landmarks can be used as features with which to train a machine learning model from which you can infer information about a person, such as their perceived age or perceived emotional state. A further application of facial analysis is to train a machine learning model to identify known individuals from their facial features. This usage is more generally known as facial recognition and involves using multiple images of each person you want to recognize to train a model so that it can detect those individuals in new images on which it wasn't trained. There are many applications for face detection, analysis, and recognition. Let's review a few examples. Security. Facial recognition can be used in building security applications, and increasingly it is used in smartphones, operating systems for unlocking devices. Social media. Facial recognition can be used to automatically tag known friends in photographs. Intelligent monitoring. For example, an automobile might include a system that monitors the driver's face to determine if the driver is looking at the road, looking at a mobile device, or shows signs of tiredness. Advertising. Analyzing faces in an image can help direct advertisements to an appropriate demographic audience. Missing persons. Using public camera systems, facial recognition can be used to identify if a missing person is in the image frame. And identity validation. Useful at ports of entry kiosks where a person holds a special entry permit. Let's get started with face analysis on Azure. Microsoft Azure provides multiple cognitive services that you can use to detect and analyze faces, including computer vision, which offers face detection and some basic face analysis, such as determining age. Video indexer, which you can use to detect and identify faces in a video. And face, which offers pre-built algorithms that can detect, recognize, and analyze faces. Face currently supports the following functionalities: face detection, face verification, find similar faces, group faces based on similarities, and identify people. Face can return the rectangle coordinates for any human faces that are found in an image, as well as a series of attributes related to those faces. These include A guess at an age, how blurred the face is, which can be an indication of how likely the face is to be the main focus of the image, what emotion is displayed, the estimated facial hair presence, whether the person in the image is smiling, the face's orientation in a 3D space, whether the face in the image has makeup applied, the hair type and hair color, if the person is wearing glasses, the visual noise in the image. A photo taken with a high sensitivity setting for darker scenes may have noise in the image. That is to say that the image looks grainy or full of tiny dots that make the image less clear. And if there are objects blocking the face in the image. To use Face, you must create one of the following types of resource in your Azure subscription. Face. You'll use this specific resource type if you don't intend to use any other cognitive services, or if you want to track utilization and costs for Face separately. And Cognitive Services, a general cognitive services resource that includes computer vision along with many other cognitive services, such as computer vision, text analytics, translated text, and others. You'll use this resource type if you plan to use multiple cognitive services and want to simplify administration and development. Whichever type of resource you choose to create, it will provide two pieces of information that you will need to use it. An endpoint that provides the HTTP address at which your resource can be accessed, and a key that is used to authenticate client applications. It's important to note that if you create a cognitive services resource, client applications use the same key and endpoint regardless of the specific service they're using. Now, let's take a look at some considerations that can help improve accuracy of the detection in the images, such as image format. The supported image formats are JPEG, PNG, GIF, and bitmap. File size. The maximum file size the system supports is 6 megabytes. And face size. The minimum detectable face size is 36 by 36 pixels with a maximum detectable face size of 4096 by 4096 pixels. Faces outside of this range will not be detected. Face detection can also be impaired by extreme face angles and occlusion, objects blocking the face, such as sunglasses or a hand. Best results are obtained when the faces are full frontal or as near as possible to full frontal. Hello and welcome. In this lesson, you'll learn how to read text and images with a computer vision service. The ability for computer systems to process written or printed text is an area of AI where computer vision intersects with natural language processing. You need computer vision capabilities to read the text, and then you need natural language processing capabilities to make sense of it. The basic foundation of processing printed text is optical character recognition, also known as OCR, in which a model can be trained to recognize individual shapes, such as letters, numerals, punctuation, or other elements of text. The postal services were one of the first industries to implement this capability by facilitating automatic mail sorting based on postal codes. Since then, the state-of-the-art for reading text has moved on, and it's now possible to build models that can detect printed or handwritten text in an image and read it line by line or even word by word. At the other end of the scale, there is machine reading comprehension, or MRC, in which an AI system not only reads the text characters, but can use a semantic model to interpret what the text is about. In this lesson, you'll focus on the use of OCR technologies to detect text and images and convert it into a text-based data format, which can then be stored, printed, or used as input for further processing or analysis. The ability to recognize printed and handwritten text in images is beneficial in many scenarios, such as note-taking, digitizing forms, such as medical records or historical documents, and scanning printed or handwritten checks for bank deposits. Let's get started with OCR on Microsoft Azure. The ability to extract text from images is handled by the Computer Vision service, which also provides image analysis capabilities. To use the Computer Vision service, you need to create a resource for it in your Azure subscription. You can use either of the following resource types: Computer Vision or Cognitive Services. Let's start off with Computer Vision. Computer Vision is a specific resource for the Computer Vision service. You use this resource type if you don't intend to use any other cognitive services, or if you want to track utilization and costs for your computer vision resource separately. Now, let's take a look at cognitive services. Cognitive services is a general cognitive services resource that includes computer vision along with many other cognitive services,
such as text analytics and translator text. You use this resource type if you plan to use multiple cognitive services and want to simplify administration and development. Whichever type of resource you choose to create, it'll provide two pieces of information that you will need to use it: an endpoint that provides the HTTP address at which your resource can be accessed, and a key that is used to authenticate client applications.
It's important to note that if you create a cognitive services resource, client applications use the same key and endpoint regardless of the specific service they're using. Images often contain typewritten or handwritten text. Some common examples are images with road signs, scanned documents that are in an image format, such as JPEG or PNG file formats, or even just a picture taken of a whiteboard that was used during a meeting. The Computer Vision service provides two application programming interfaces, or APIs, that you can use to read text in images: the OCR API and the Read API. Let's start by reviewing the capabilities of the OCR API. The OCR API is designed for quick extraction of small amounts of text in images. It operates synchronously to provide immediate results and can recognize text in numerous languages. When you use the OCR API to process an image, it returns a hierarchy of information that consists of regions in the image that contain text, lines of text in each region, and words in each line of text. For each of these elements, the OCR API also returns bounding box coordinates that define a rectangle to indicate the location in the image where the region, line, or word appears. The OCR method can have issues with false positives when the image is considered text dominant. Now, let's take a look at the capabilities of the Read API. The Read API uses the latest recognition models and is optimized for images that have a significant amount of text or have considerable visual noise. The Read API is a better option for scanned documents that have a lot of text. The Read API also has the ability to automatically determine the proper recognition model to use, taking into consideration lines of text and supporting images with printed text, such as recognizing handwriting. Because the Read API can work with larger documents, it works asynchronously, so as not to block your application while it is reading the content and returning results to your application. This means that to use the Read API, your application must use a three-step process. First, it submits an image to the API and retrieves an operation ID in response. Then, it uses the operation ID to check on the status of the image analysis operation and waits until it has completed. And finally, it retrieves the results of the operation. The results from the Read API are arranged in the following hierarchy. Pages. One for each page of text, including information about the page size and orientation. Lines. The lines of text on a page. And words. The words in a line of text. Each line and word includes bounding box coordinates indicating its position on the page. Welcome. In this lesson, we will look at using the Form Recognizer service to automate data extraction from receipts, invoices, and other form-related documents. Processing invoices and receipts is a common task in many business scenarios. Increasingly, organizations are turning to artificial intelligence to automate data extraction from scanned receipts. For example, a company might require expense claims to be submitted electronically with scanned receipts, or invoices might need to be digitized and routed to the correct accounts department. After completing this lesson, you will be able to use the built-in receipt processing capabilities of the Form Recognizer service, scanning receipts into digital images or PDF documents, and then using OCR technologies to extract the text contents from the digitized documents is an easy process. However, with this process, often someone still needs to review the OCR extracted text and make sense of the information it contains. For example, this receipt contains information that might be required for an expense claim, including the name, address, and telephone number of the merchant, the date and time of the purchase, the quantity and price of each item purchased, and the subtotal tax, and total amounts. Increasingly, organizations with large volumes of receipts and invoices to process are looking for artificial intelligence solutions that can not only extract the taxed data from receipts, but also intelligently interpret the information they contain. The Form Recognizer in Azure provides intelligent form processing capabilities that you can use to automate the processing of data in documents such as forms, invoices, and receipts. It combines state-of-the-art optical character recognition with predictive models that can interpret form data by matching field names to values, processing tables of data, identifying specific types of field such as dates, telephone numbers, addresses, totals, and others. Form Recognizer supports automated document processing through a pre-built receipt model that is provided out of the box and is trained to recognize and extract data from sales receipts. Custom models, which enable you to extract what are known as key-value pairs and table data from forms. Custom models are trained using your own data, which helps to tailor this model to your specific forms. Starting with only 5 samples of your forms, you can train the custom model. After the first training exercise, you can evaluate the results and consider if you need to add more samples and retrain. The next hands-on exercise will only step through a pre-built receipt model. If you would like to train a custom model, you can refer to the Form Recognizer documentation. A link is provided in the Additional Resources section. To use the Form Recognizer in your Azure subscription, you need to create either a Form Recognizer resource or a Cognitive Services resource. Both resource types give you access to the Form Recognizer service. After the resource has been created, client applications can use its key and its endpoint to connect and submit forms for analysis. Currently, the pre-built receipt model is designed to recognize common receipts in English that are common to the USA. Example documents are receipts used at restaurants, retail locations, and gas stations. The model can extract key information from the receipt slip, recognizing items such as time of transaction, date of transaction, merchant information, taxes paid, receipt totals, other pertinent information that may be present on the receipt, and all other text on the receipt is also recognized and returned. Use the following guidelines to get the best results when using a custom model. Images must be JPEG, PNG, bitmap, PDF, or TIFF formats. The file size must be less than 50 megabytes. The image size must be between 50 by 50 pixels and 10,000 by 10,000 pixels. And for PDF files, the document can be no larger than 17 inches by 17 inches. There's a free tier subscription plan for the receipt model along with paid subscriptions. For the free tier, only the first 200 pages will be processed when passing in PDF or TIFF formatted documents. Congratulations! You've completed the final lesson in this course. Explore computer vision in Microsoft Azure. Please remember to clean up. If you don't intend to experiment any further, you should delete the endpoint to avoid accruing unnecessary Azure usage. And you should also stop the compute instance until you need it again. You can access the process in the reading on Cleanup.
In this course, you learned how to use the computer vision cognitive service to analyze images, use the custom vision service to create an image classification solution, and use the custom vision service to create an object detection solution. You also explored the face detection features of the computer vision and video indexer services and used the face service and associated APIs for facial detection. You saw how both the OCR API and the Read API provide the ability to extract text from images and use the Read API service in large text scenarios. And you used the pre-built receipt model as a part of the Form Recognizer service to help automate expense workflows for businesses by extracting key data from the receipts. While the computer vision and video indexer services offer face detection features, the face service and associated APIs provide more capabilities. Which you choose will ultimately depend on the insights you want to gain from facial detection. If you want to look for data around facial landmarks, face is the proper choice. Optical character recognition, or OCR, has been around for a long time. The ability to recognize and extract text from documents was one of the earliest uses. The ability to do the same extraction from images is where the OCR API and the Read API can help. Both of the APIs provide the ability to extract text from images. The text can be typewritten or handwritten and can be at different angles within the image. The main factor in choosing which API to use is determined by the amount of text that needs to be processed. The Read API is the service that is optimized for large text scenarios. The pre-built receipt model is a part of the Form Recognizer service. It is optimized to extract information from receipts. Capable of reading from restaurant, retail, and gas company receipts, it can help automate expense workflows for businesses by extracting key data from the receipts. You are one step further down the road to certification. Microsoft Azure certifications validate the skills and knowledge that you demonstrate. Successfully completing this program can help you to develop your career goals as well as open up further career opportunities.
Hello and welcome. In this course, you'll be exploring natural language processing in Microsoft Azure. Natural language processing supports applications that can see, hear, speak with, and understand users. Using text analytics, translation, and language understanding services, Microsoft Azure makes it easy to build applications that support natural language. In this course, you'll learn to identify features of common natural language processing workload scenarios, identify Microsoft Azure tools and services for natural language processing workloads, identify common use cases for conversational AI, and finally, you will learn to identify Microsoft Azure services for conversational AI. The best way to learn is to explore. You'll work through a number of practical exercises. To complete the practical exercises, you will make use of a virtual lab environment. You'll be provided with the guidelines you need to access the labs at the start of each exercise. To complete the practical exercises, you'll need an Azure subscription. If you don't already have an Azure subscription, you can sign up for a free trial by accessing the Microsoft Azure webpage or by using the link provided. You'll find more detail on how to create an Azure subscription later in this course. You'll also have an opportunity to complete interactive exercises that give you the opportunity to gain hands-on experience. Knowledge checks that will keep you on track and let you know how you are doing and what you've learned so far, and test prep questions, which you can use to check your progress. This hands-on approach will help you in your preparation for the AI 900 exam. Once you successfully complete this course, you'll be awarded a Coursera certificate. Good luck with your preparation. Welcome. In this lesson, you are going to look at the text analytics service to perform analysis of text. Analyzing text is a process where you evaluate different aspects of a document or phrase in order to gain insight into the content of that text. The Text Analytics Service is a cloud-based service that provides advanced natural language processing of raw text for sentiment analysis, key phrase extraction, named entity recognition, and language detection. After completing this lesson, you'll be able to use the Text Analytics Service to perform analysis of text. For the most part, humans are able to read some text and understand the meaning behind it. Even without considering the grammar rules for the language the text is written in, specific insights can be identified in the text. As an example, you might read some text and identify some key phrases that indicate the main talking points of the text. You might also recognize names of people or well-known landmarks such as the Eiffel Tower. Although difficult at times, you might also be able to get a sense for how the person was feeling when they wrote the text, also commonly known as sentiment. Text analytics is a process where an AI algorithm running on a computer evaluates these same attributes in text to determine specific insights. A person will typically rely on their own experiences and knowledge to achieve the insights. A computer must be provided with similar knowledge to be able to perform the evaluation task. Some of the techniques frequently used to build text analyzing software include statistical analysis of terms used in the text. For example, removing common stop words, words like the or a, which reveal little semantic information about the text, and performing frequency analysis of the remaining words, counting how often each word appears, can provide clues about the main subject of the text. Extending frequency analysis to multi-term phrases, commonly known as n-grams. A two-word phrase is a bigram, a three-word phrase is a trigram, and so on. Applying stemming or lemmatization algorithms to normalize words before counting them, For example, so that words like power, powered, and powerful are interpreted as being the same word. Applying linguistic structure rules to analyze sentences. For example, breaking down sentences into tree-like structures, such as a noun phrase, which itself contains nouns, verbs, and adjectives, and so on. Encoding words and terms as numeric features that can be used to train a machine learning model. For example, to classify a text document based on the terms it contains. This technique is often used to perform sentiment analysis, in which a document is classified as positive or negative. Creating vectorized models that capture semantic relationships between words by assigning them locations in n-dimensional space. This modeling technique might, for example, assign values to the words flower and plant that locate them close to one another, while skateboard might be given a value that positions it much further away. While these techniques can be used to great effect, programming them can be complex. In Microsoft Azure, the Text Analytics Cognitive Service can help simplify application development by using pre-trained models that can determine the language of a document or text, for example, French or English. Perform sentiment analysis on text to determine a positive or negative sentiment. Extract key phrases from text that might indicate its main talking points. Entities can be people, places, organizations, or even everyday items, such as dates, times, quantities, and so on. In this lesson, you'll explore some of these text analytics cognitive service capabilities and gain an understanding of how you might apply them to applications such as a social media feed analyzer to detect sentiment around a political campaign or product in market, a document search application that extracts key phrases to help summarize the main subject matter of documents in a catalog, a tool to extract brand information or company names from documents or other text for identification purposes. These examples are just a small sample of the many areas that text analytics can help with. The Text Analytics Service is a part of the Azure Cognitive Services offerings that can perform advanced natural language processing over raw text. To use the Text Analytics Service in an application, you must provision an appropriate resource in your Azure subscription. You can choose to provision either of the following types of resource. A Text Analytics resource. Choose this resource type if you only plan to use the Text Analytics service, or if you want to manage access and billing for the resource separately from other services. A Cognitive Services resource. Choose this resource type if you plan to use the Text Analytics service in combination with other cognitive services, and you want to manage access and billing for these services together. Use the language detection capability of the Text Analytics service to identify the language in which text is written. You can submit multiple documents at a time for analysis. For each document submitted to it, the service will detect the language name, for example English, the ISO 6391 language code, for example EN, and a score indicating a level of confidence in the language detection. For example, consider a scenario where you own and operate a restaurant. The customers complete surveys to provide feedback on the food, the service, staff, and so on. You can use the Text Analytics service to detect the language for each of these reviews, and it might respond with these results. Notice that the language detected for Review 3 is English, despite the text containing a mix of English and French. The language detection service will focus on the predominant language in the text. The service uses an algorithm to determine the predominant language, such as length of phrases or total amount of text for the language, compared to other languages in the text. The predominant language will be the value returned, along with the language code. The confidence score may be less than 1 as a result of the mixed language text. There may be text that is ambiguous in nature or that has mixed language content. These situations can present a challenge to the service. An ambiguous content example would be a case where the document contains limited text or only punctuation. For example, using the service to analyze this text results in a value of unknown for the language name and the language identifier, and a score of NaN, which is used to indicate not a number. The Text Analytics service can evaluate text and return sentiment scores and labels for each sentence. This capability is useful for detecting positive and negative sentiment in social media, customer reviews, discussion forums, and more. Using the pre-built machine learning classification model, the service evaluates the text and returns a sentiment score in the range of 0 to 1. with values closer to 1 being a positive sentiment. Scores that are close to the middle of the range, 0.5, are considered neutral or indeterminate. For example, 2 restaurant reviews could be analysed for sentiment. The sentiment score for one review that contains terms like amazing, clean, and courteous might be around 0.9, indicating a positive sentiment, while the score for a second review that contains terms like worst and awful might be closer to 0.1, indicating a negative sentiment. A score of 0.5 might indicate that the sentiment of the text is indeterminate. This could result from text that does not have sufficient context or insufficient phrasing to discern a sentiment. For example, a list of words in a sentence that has no structure could result in an indeterminate score. Another example where a score may be 0.5 is in the case where the wrong language code was used. A language code, such as EN for English or FR for French, is used to inform the service which language the text is in. If you pass text in French but tell the service the language code is EN for English, the service will return a score of precisely 0.5. Key phrase extraction is the concept of evaluating the text of a document or documents, and then identifying the main talking points of the documents. Consider the restaurant scenario discussed previously. Depending on the volume of surveys that you've collected, it can take a long time to read through the reviews. Instead, you can use the key phrase extraction capabilities of the text analytics service to summarize the main points. For example, key phrase extraction can provide some context to this review by extracting these phrases: a tentative service, great food, birthday celebration, fantastic experience, table, friendly hostess, dinner, ambience, and place. Not only can you use sentiment analysis to determine that the review is positive, you can use the key phrases to identify important elements of the review. You can provide the text analytics service with unstructured text, and it will return a list of entities in the text that it recognizes. The service can also provide links to more information about that entity on the web. An entity is essentially an item of a particular type or a category, and in some cases subtype, such as those shown in this table. The service also supports entity linking to help disambiguate entities by linking to a specific reference. For recognized entities, the service returns a URL for a relevant Wikipedia article. This entity table is available to view in the additional resources of this lesson. For example, let's see the text analytics service detecting entities in a restaurant review extract that says, "I ate at the restaurant in Seattle last week." It would locate the entities of Seattle and last week. These are of a particular type, category, and subtype. Welcome. In this lesson, you learn how to recognize and synthesize speech using Microsoft Azure Cognitive Services. Increasingly, we expect artificial intelligence solutions to accept vocal commands and provide spoken responses. Consider the growing number of home and auto systems that you can control by speaking to them. Issuing commands such as turn off the lights, and soliciting verbal answers to questions such as, will it rain today? To enable this kind of interaction, the AI system must support 2 capabilities. Speech recognition, the ability to detect and interpret spoken input, and speech synthesis, the ability to generate spoken output. Speech recognition is concerned with taking the spoken word and converting it into data that can be processed, often by transcribing it into a text representation. The spoken words can be in the form of a recorded voice in an audio file, or live audio from a microphone. Speech patterns are analyzed in the audio to determine recognizable patterns that are mapped to words. To accomplish this feat, the software typically uses multiple types of model, including an acoustic model that converts the audio signal into phonemes, representations of specific sounds, and a language model that maps phonemes to words, usually using a statistical algorithm that predicts the most probable sequence of words based on the phonemes. The recognized words are typically converted to text, which you can use for various purposes, such as providing closed captions for recorded or live videos, creating a transcript of a phone call or meeting, automated note dictation, and determining intended user input for further processing. Speech synthesis is in many ways the reverse of speech recognition. It is concerned with vocalizing data, usually by converting text to speech. A speech synthesis solution typically requires the following information: the text to be spoken and the voice to be used to vocalize the speech. To synthesize speech, the system typically tokenizes the text to break it down into individual words and assigns phonetic sounds to each word. It then breaks the phonetic transcription into prosodic units, such as phrases, clauses, or sentences, to create phonemes that will be converted to audio format. These phonemes are then synthesized as audio by applying a voice which will determine parameters such as pitch and timbre, and generating an audio waveform that can be output to a speaker or written to a file. You can use the output of speech synthesis for many purposes, including generating spoken responses to user input, creating voice menus for telephone systems, reading email or text messages aloud in hands-free scenarios, and broadcasting announcements in public locations, such as railway stations or airports. Microsoft Azure offers both speech recognition and speech synthesis capabilities through the Speech Cognitive Service, which includes the following application programming interfaces, or APIs: the Speech-to-Text API and the Text-to-Speech API. To use the speech service in an application, you must provision an appropriate resource in your Azure subscription. You can choose to provision either of the following types of resource: a speech resource. Choose this resource type if you only plan to use the speech service, or if you want to manage access and billing for the resource separately from other services. And a cognitive services resource. Choose this resource type if you plan to use the speech service in combination with other cognitive services, and you want to manage access and billing for these services together. You can use the Speech-to-Text API to perform real-time or batch transcription of audio into a text format. The audio source for transcription can be real-time audio stream from a microphone or an audio file. The model that is used by the Speech-to-Text API is based on the Universal Language Model that was trained by Microsoft. The data for the model is Microsoft-owned and deployed to Microsoft Azure. The model is optimized for two scenarios: conversational and dictation. You can also create and train your own custom models, including acoustics, language, and pronunciation, if the pre-built models from Microsoft do not provide what you need. Real-time speech-to-text allows you to transcribe text in audio streams. You can use real-time transcription for presentations, demos, or any other scenario where a person is speaking. In order for real-time transcription to work, your application will need to be listening for incoming audio from a microphone or other audio input source, such as an audio file. Your application code streams the audio to the service, which returns the transcribed text. Not all speech-to-text scenarios are real-time. You may have audio recordings stored on a file share, a remote server, or even on Azure storage. You can point to audio files with a shared access signature URL and asynchronously receive transcription results. Batch transcription should be run in an asynchronous manner because the batch jobs are scheduled on a best effort basis. Normally, a job will start executing within minutes of the request, but there is no estimate for when a job changes into the running state. The Text-to-Speech API enables you to convert text input to audible speech, which can either be played directly through a computer speaker or written to an audio file. When you use the Text-to-Speech API, you can specify the voice to be used to vocalize the text. This capability offers you the flexibility to personalize your speech synthesis solution and give it a specific character. The service includes multiple predefined voices with support for multiple languages and regional pronunciation, including standard voices as well as neural voices that leverage neural networks to overcome common limitations in speech synthesis with regard to intonation, resulting in a more natural sounding voice. You can also develop custom voices and use them with the Text-to-Speech API. Both the Speech-to-Text and Text-to-Speech APIs support a variety of languages. Use the links provided in the additional resources section of this lesson to find out more details about the supported languages. Congratulations! You've completed this week's learning where you looked at text analytics, speech recognition, and speech synthesis. Speech recognition is concerned with taking the spoken word and converting it into a text representation, while speech synthesis is the process of converting text data to audible speech. Both tasks are supported by the Speech Cognitive Service. You looked at the Microsoft Azure resources for the speech service and had a hands-on exploration of the service, using it to perform some sample speech recognition and synthesis. The Text Analytics Service provides advanced natural language processing over raw text and includes 4 main functions: sentiment analysis, key phrase extraction, language detection, and named entity recognition. Demonstrating knowledge of these topics is a requirement in the AI 900 Microsoft Azure AI Fundamentals exam. You are one step further down the road to certification. Hello and welcome. In this lesson, you'll learn how to perform text and speech translation using cognitive services on Microsoft Azure. Let's dive right in. As organizations and individuals increasingly need to collaborate with people from other cultures and geographic locations, the removal of language barriers has become a significant problem. One solution is to find bilingual or even multilingual people to translate between languages. However, the scarcity of such skills and the number of possible language combinations can make this approach difficult to scale. Increasingly, automated translation, sometimes known as machine translation, is being employed to solve this problem. Early attempts at machine translation applied literal translations. A literal translation is where each word is translated to the corresponding word in the target language. This approach presents some issues. For one case, there may not be an equivalent word in the target language. Another case is where literal translation can change the meaning of the phrase or not get the context correct. Let's take a look at an example. The French phrase éteindre la lumière can be translated to English as turn off the light. However, in French, you might also say fermer la lumière to mean the same thing. The French verb fermer literally means to close, so a literal translation based only on the words would indicate in English, close the light, which for the average English speaker doesn't really make sense. So to be useful, a translation service should take into account the semantic context and return an English translation of turn off the light. Semantics, or the study of relationships between words and how we construct meaning, sheds light on how we experience the world and how we understand others and ourselves. Artificial intelligence systems must be able to understand not only the words, but also the semantic context in which they are used. In this way, the service can return a more accurate translation of the input phrase or phrases. The grammar rules, formal versus informal, and colloquialisms all need to be considered. Let's get started with translation in Microsoft Azure. Microsoft Azure provides cognitive services that support translation. Specifically, you can use the Translator Text Service, which supports text-to-text translation, the Speech Service, which enables speech-to-text and speech-to-speech translation. Before you can use the translator text or speech services, you must provision appropriate resources in your Azure subscription. There are dedicated translator text and speech resource types for these services, which you can use if you want to manage access and billing for each service individually. Alternatively, you can create a cognitive services resource that provides access to both services through a single Azure resource. This means you consolidate billing and enable applications to access both services through a single endpoint and authentication key. Let's start off reviewing text translation with the Translator Text Service. The Translator Text Service is easy to integrate into your applications, websites, tools, and solutions. The service uses a neural machine translation, or NMT model for translation, which analyzes the semantic context of the text and renders a more accurate and complete translation as a result. The Text Translator service supports text-to-text translation between more than 60 languages. When using the service, you must specify the language you are translating from and the language you are translating to using ISO 6391 language codes, such as EN for English, FR for French, and ZH for Chinese. Alternatively, you can specify cultural variants of languages by extending the language code with the appropriate 31661 cultural code. For example, EN US for US English, ENGB for British English, or FRCA for Canadian French. When using the text translator service, you can specify one from language with multiple to languages, enabling you to simultaneously translate a source document into multiple languages. The Translator Text API offers some optional configuration to help you fine-tune the results that are returned, including profanity filtering and selective translation. Let's first take a closer look at how you can use profanity filtering. Without any configuration, the service will translate the input text without filtering out profanity, although profanity levels are typically culture-specific. Using profanity filtering, you can control profanity translation by either marking the translated text as profane or by omitting it in the results. Now let's look at what you can do with selective translation. Using selective translation, you can tag content so that it isn't translated. For example, you may want to tag code, a brand name, or a word or phrase that doesn't make sense when localized. Let's review speech translation with the speech service. The speech service includes the following APIs. Speech to text, used to transcribe speech from an audio source to text format. Text to speech, used to generate spoken audio from a text source. And speech translation, used to translate speech in one language to text or speech in another. You can use the speech translation API to translate spoken audio from a streaming source, such as a microphone or audio file, and return the translation as text or an audio stream. This enables scenarios such as real-time closed captioning for a speech or simultaneous two-way translation of a spoken conversation. As with the translator text service, you can specify one source language and one or more target languages to which the source should be translated. You can translate speech into over 60 languages. The source language must be specified using the Extended Language and Culture Code format, such as ES-US for American Spanish. This requirement helps ensure that the source is understood properly, allowing for localized pronunciation and linguistic idioms. The target language must be specified using a 2-character language code, such as EN for English or DE for German. Hello and welcome. In this lesson, I'll introduce you to the Language Understanding Service and show you how to create applications that understand language. After completing this lesson, you'll be able to explain what language understanding is, identify key features such as intents and utterances, and build and publish a natural language machine learning model. In 1950, the British mathematician Alan Turing devised the imitation game, which has become known as the Turing test, and hypothesizes that if a dialogue is natural enough, you may not know whether you're conversing with a human or a computer. As artificial intelligence grows ever more sophisticated, this kind of conversational interaction with applications and digital assistants is becoming more and more common, and in specific scenarios can result in human-like interactions with AI agents. Common scenarios for this kind of solution include customer support applications, reservation systems, and home automation, among others. To realize the aspiration of the imitation game, computers need not only to be able to accept language as input, either in text or audio format, but also to be able to interpret the semantic meaning of the input. In other words, understand what is being said. On Microsoft Azure, language understanding is supported through the Language Understanding Intelligence Service, or LUIS, more commonly known as language understanding. To work with language understanding, you need to take into account 3 core concepts: utterances, entities, and intents. An utterance is an example of something a user might say, and which your application must interpret. For example, when using a home automation system, a user might use the following utterances: switch the fan on, or turn on the light. An entity is an item to which an utterance refers. For example, fan and light in the following utterances: switch the fan on, or turn on the light. You can think of the fan and light entities as being specific instances of a general device entity. An intent represents the purpose or goal expressed in a user's utterance. For example, for both of the previously considered utterances, the intent is to turn a device on. So in your language understanding application, you might define a turn-on intent that is related to these utterances. A language understanding application defines a model consisting of intents and entities. Utterances are used to train the model to identify the most likely intent and the entities to which it should be applied based on a given input. You'll work through more examples using the home automation system scenario. Before you start, let's recap on the 3 core concepts when working with language understanding. An utterance is input from the user that your app needs to interpret. An intent represents a task or action the user wants to do. It's a purpose or goal expressed in a user's utterance. The intent should be a concise way of grouping the utterance tasks. And an entity represents a word or phrase inside the utterance that you want to extract. Now you'll work through the examples. In this scenario, the Home Assistant application includes multiple intents. There are also numerous utterances used for each of the intents. Let's dive right in. In this scenario, the related utterances are hello, hi, hey, and good morning. Remember, the intent should be a concise way of grouping the utterance tasks. In this case, all the utterances are greetings. Therefore, the intent is greeting. The next related utterances are switch the fan on, turn the light on, and turn on the light. The intent in this instance is turn on, and the entities are the devices mentioned in the utterances, which are the fan and the light. Let's continue with a further example. In this scenario, the intent is check weather. The related utterances are what is the weather for today? Give me the weather forecast. What is the forecast for Paris? What will the weather be like in Seattle tomorrow? Remember, an entity represents a word or phrase inside the utterance that you want to extract. In this scenario, the entities are today, date or time, Paris, location, Seattle, location, and tomorrow, date or time. Lastly, utterances such as what is the meaning of life and is this thing on are grouped with the none intent. You should consider always using the none intent to help handle utterances that do not map any of the utterances you've entered. The none intent is considered a fallback and is typically used to provide a generic response to users when the requests don't match any other intent. In a language understanding application, the none intent is created but left empty on purpose. The none intent is a required intent and can't be deleted or renamed. Fill it with utterances that are outside of your domain. After defining the entities and intents with sample utterances in your language understanding application, you can train a language model to predict intents and entities from user input, even if it doesn't match the sample utterances exactly. You can then use the model from a client application to retrieve predictions and respond appropriately. Let's get started with language understanding. Creating a language understanding application with language understanding consists of 2 main tasks. First, you must define entities, intents, and utterances with which to train the language model, referred to as authoring the model. Then you must publish the model so that client applications can use it for intent and entity prediction based on user input. For each of the authoring and prediction tasks, you need a resource in your Azure subscription. You have the choice of using either language understanding, a dedicated resource for language understanding, which can be either an authoring or a prediction resource, or cognitive services, a general cognitive services resource that includes language understanding, along with many other cognitive services. You can only use this type of resource for prediction. The separation of authoring and prediction resources is useful when you want to track resource utilization for language model training separately from client applications using the model to generate predictions. If you choose to create a language understanding resource, you will be prompted to choose authoring, prediction, or both. And it's important to note that if you choose both, then 2 resources are created, one for authoring and one for prediction. Alternatively, you can use a dedicated language understanding resource for authoring, but deploy your model to a generic cognitive services resource for prediction. When your client application uses other cognitive services in addition to language understanding, This approach enables you to manage access to all of the cognitive services being used, including the language understanding prediction service, through a single endpoint and key. After you've created an authoring resource, you can use it to author and train a language understanding application by defining the entities and intents that your application will predict, as well as utterances for each intent that can be used to train the predictive model. Language understanding provides a comprehensive collection of pre-built domains that include predefined intents and entities for common scenarios, which you can use as a starting point for your model. You can also create your own entities and intents. When you create entities and intents, you can do so in any order. You can create an intent and select words in the sample utterances you define for it to create entities for them. Or you can create the entities ahead of time and then map them to words in utterances as you're creating the intents. You can write code to define the elements of your model, but in most cases, it's easiest to author your model using the Language Understanding Portal, a web-based interface for creating and managing language understanding applications. Best practice is to use the Language Understanding Portal for authoring and to use the SDK for runtime predictions. After you've created an authoring resource, you can use it to author and train a language understanding application by defining the entities and intents that your application will predict, as well as utterances for each intent that can be used to train the predictive model. So how do you create intents? Define intents based on actions a user would want to perform with your application. For each intent, you should include a variety of utterances that provide examples of how a user might express the intent. If an intent can be applied to multiple entities, be sure to include sample utterances for each potential entity, and ensure that each entity is identified in the utterance. Now let's take a look at creating entities. There are 4 types of entities. Machine-learned entities are learned by your model during training from context in the sample utterances you provide. List entities are defined as a hierarchy of lists and sublists. For example, a device list might include sublist for light and fan. For each list entry, you can specify synonyms, such as lamp for light. Regex entities are defined as a regular expression that describes a pattern. For example, you might define a pattern like open brackets 0 to 9, close brackets, open brace 3, close brace, dash, open brackets 0 to 9, close brackets, dash, open brace 4, close brace, for telephone numbers of the form 555-123-4567. Pattern.any entities are used with patterns to define complex entities that may be hard to extract from sample utterances. When you are satisfied with the results from the training and testing, you can publish your language understanding application to a prediction resource for consumption. After you've defined the intents and entities in your model and included a suitable set of sample utterances, the next step is to train the model. Training is the process of using your sample utterances to teach your model to match natural language expressions that a user might say to probable intents and entities. Client applications, such as a chatbot, can use the model by connecting to the endpoint for the prediction resource, specifying the appropriate authentication key, and submit user input to get predicted intents and entities. The predictions are returned to the client application, which can then take appropriate action based on the predicted intent. Congratulations, you've completed this week's lesson. This week, you explored language understanding. You learned how to use the language understanding to build a model that predicts intents and entities from natural language utterances. You also learned that a client application can then use this trained model to respond to natural language user input. Demonstrating knowledge of these topics is a requirement in the AI 900 exam. You are now one step further down the road to certification. Hello and welcome. In this lesson, you'll learn how to create a Q&A Maker knowledge base with an Azure Bot Service Bot in Microsoft Azure. Let's dive right in. In today's connected world, people use a variety of technologies to communicate. For example, voice calls, messaging services, online chat applications, email, social media platforms, and collaborative workplace tools. We've become so used to ubiquitous connectivity that we expect the organizations we deal with to be easily contactable and immediately responsive through the channels we already use. Additionally, we expect these organizations to engage with us individually and be able to answer complex questions at a personal level. While many organizations publish support information and answers to frequently asked questions, or FAQs, that can be accessed through a web browser or dedicated app, the complexity of the systems and services they offer means that answers to specific questions are hard to find. Often these organizations find their support personnel being overloaded with requests for help through phone calls, email, text messages, social media, and other channels. Increasingly, organizations are turning to AI solutions that make use of AI agents, commonly known as bots, to provide a first line of automated support through the full range of channels that we use to communicate. Bots are designed to interact with users in a conversational manner. An example is a chat interface, such as you might find on a website. Bots can be designed to work across multiple channels, including email, social media platforms, and even voice calls. Regardless of the channel used, bots typically manage conversation flows using a combination of natural language and constrained option responses that guide the user to a resolution. Conversations typically take the form of messages exchanged in turns, and one of the most common kinds of conversational exchange is a question followed by an answer. This pattern forms the basis for many user support bots and can often be based on existing FAQ documentation. Let's get started with Q&A Maker and Azure Bot Services in Microsoft Azure. You can easily create a user support bot solution on Microsoft Azure using a combination of two core technologies. Q&A Maker. This cognitive service enables you to create and publish a knowledge base with built-in natural language processing capabilities. And Azure Bot Service. This service provides a framework for developing, publishing, and managing bots on Azure. The first challenge in creating a user support bot is to use the Q&A Maker service to create a knowledge base. The service provides a dedicated Q&A Maker portal web-based interface that you can use to create, train, publish, and manage knowledge bases. You can write code to create and manage knowledge bases using the Q&A Maker REST API or SDK. However, in most scenarios, it is easier to use the Q&A Maker portal. To create a knowledge base, you must first provision a Q&A Maker resource in your Azure subscription. You can do this directly in the Azure portal before you start creating your knowledge base, or you can start developing your knowledge base in the Q&A Maker portal and provision the resource when prompted. After provisioning a Q&A Maker resource, you can use the Q&A Maker portal to create a knowledge base that consists of question and answer pairs. These questions and answers can be generated from an existing FAQ document or web page, imported from a predefined chit-chat data source, or entered and edited manually. In many cases, a knowledge base is created using a combination of all these techniques, starting with a base data set of questions and answers from an existing FAQ document, adding common conversational exchanges from a chit-chat source, and extending the knowledge base with additional manual entries. After creating a set of question and answer pairs, you must train your knowledge base. Questions in the knowledge base can be assigned alternative phrasing to help consolidate questions with the same meaning. For example, you might include a question like, "What is your head office location?" You can anticipate different ways this question could be asked by adding an alternative phrasing such as, "Where is your head office located?" This process analyzes your literal questions and answers and applies a built-in natural language processing model to match appropriate answers to questions, even when they are not phrased exactly as specified in your question definitions. After training, you can use the built-in test interface in the Q&A Maker portal to test your knowledge base by submitting questions and reviewing the answers that are returned. When you're satisfied with your trained knowledge base, you can publish it so that the client applications can use it over its REST interface. To access the knowledge base, client applications require the knowledge base ID, the knowledge base endpoint, and the knowledge base authorization key. After you've created and published a knowledge base, you can deliver it to users through a bot. You can create a custom bot by using the Microsoft Bot Framework SDK to write code that controls conversation flow and integrates with your Q&A Maker knowledge base. However, an easier approach is to use the automatic bot creation functionality of Q&A Maker, which enables you to create a bot for your published knowledge base and publish it as an Azure Bot Service application with just a few clicks. After creating your bot, you can manage it in the Microsoft Azure portal, where you can extend the bot's functionality by adding custom code, test the bot in an interactive test interface, configure logging, analytics, and integration with other services. For simple updates, you can edit bot code directly in the Azure portal. However, for more comprehensive customization, you can download the source code and edit it locally, republishing the bot directly to Azure when you're ready. When your bot is ready to be delivered to users, you can connect it to multiple channels, making it possible for users to interact with it through web chat, email, Microsoft Teams, and other common communication media. Users can submit questions to the bot through any of its channels and receive appropriate answers from the knowledge base on which the bot is based. Congratulations, you've completed this course. In this course, you explored Q&A Maker and Azure Bot Services. The Q&A Maker service enables you to define and publish a knowledge base of questions and answers with support for natural language querying. When combined with Azure Bot Service, you can use Q&A Maker to deliver a bot that responds intelligently to user questions over multiple communication channels. The ability to create conversational AI solutions with these services makes it possible for AI agents to reduce the support workload for human personnel, enabling organizations to provide user support on a global scale. Demonstrating knowledge of these topics is a requirement in the AI 900 exam. You are now one step further down the road to certification.